Okay, hello everyone. Welcome to the exciting world of 2.4 review sheet video, as promised. All right, so let's get right into it. There's four problems here. Two problems given a table, linear models, and then two problems given a slope and an initial value. So this first problem obviously is given a table. Okay, so Bang Up Motors will rent you a car per the table below. The first step is always to identify the independent and dependent variable. So we have the total cost and the miles traveled. Easily identifiable from the left-hand side of the table here, right? They're written right in the first column. Okay, so we have to decide which one is which. Does the total cost depend on the miles traveled? Does the miles traveled depend on the total cost? You are correct. If you said to yourself, the total cost depends on the miles traveled, the dependent variable depends on the independent variable. Or you can think about it in terms of cause and effect. The miles traveled, the cause affects the total cost, okay? So the independent variable is the cause and the dependent variable is the effect. All right, so once we identified it, I'm just going to label it so we can correctly name the variable and input it into the equation using function notation appropriately. So the total cost, dependent variable, dependent, so I'm screwy for a second, and miles traveled, independent. Okay, I'm abbreviating indep and dep, independent and dependent. Okay, next step, let's name the variables. We always capitalize the dependent variable, so it makes sense to me to call the total cost C. I'm just going to write that down. You don't necessarily need to write this when you do the problems in the quiz, but I do want you to see that you're naming variables that make sense. For instance, if this was a problem like this, and then you said to me, oh, it's X because it's xylophones, no, that's not going to make any sense at all. I want the total cost to be C because of cost, obviously, and then lowercase m represents the miles, or the miles traveled. Okay, next step. Before we start developing the equation, let's think about what we want to put in the equation. All right, so we have the left-hand side all set. In function notation, it's C of m. What's in the right-hand side? It is the slope, right? Here, the slope times whatever the initial, times the independent variable. In this case, I'll use x, and then plus the initial value, right? So mx plus b. But we need to be inputting values for this slope and the initial value, which I'm boxing in red. We need to put numbers in there. How do we solve that? We get that from the table. So let's do that work right now. Okay, first let's start with the slope. Easy enough. We have multiple sets of coordinate points. We can choose any two. I'm going to choose the easiest two, and I'm going to say that this is x1, right, y1. I've identified x and y because I know that the total cost is the dependent variable and the miles traveled is the independent variable. And this is x2, y2, the next set of coordinate points. So that's why it's important identifying the independent and dependent variables, because you want to input them into the slope formula appropriately, or else you'll have the reciprocal of what you actually need to be the slope. So let's calculate this. The slope is equal to 28, subtract 2650 over, that's y2 minus y1, 20 minus 10, which is equal to 150 over 10, right? 150 divided by 10. Note that for this test, you'll have a calculator, so you need not to worry. You'll have the calculator available to you. You don't need to think about too critically. I don't want to test your arithmetic skills, division, although I feel like this is important. I want to just make sure you understand this. But if we were to put this in the calculator, we could easily see 1.5 divided by 10 is 0.15. That's the value of m. You solve for m. I put an extra leg on the m. I don't know why. M. Jess. Okay, next. I'm going to erase x2 and y2 up here just so we can work with these same two values. But for the initial value here, okay, so this is a change in the table, right, that's occurring. It's plus 10. We've identified that because 20 minus 10 is 10 already too. Here we have, this is plus 150. So if I want to revert back to the x being 0, or the independent variable being 0, I just go back 1, okay, and subtract 10 from 10, and then I know that I need to go back only 1 from 2650, subtract 150, which is 25. So I'm actually dealing with a coordinate point here. My coordinate point is 0, 25, making my initial value 25. So I'm just going to R raise mx plus b and input what I have. All right, so I solve for m, I solve for b. I'm not going to put x because I know I've named my independent variable. So that's going to be 0.15 m, because that's the independent variable. Note that m is not the slope. M is the miles in this case. That's what I've named the independent variable, plus 25. So in my answer for A, this is what I'm boxing out. C of m is equal to 0.15 m plus 25. Okay, next part. What is the cost of renting a car and driving 1,200 miles? Okay, in all these problems, and you'll reference this, of course, on your paper, but I need to rewrite this equation. I'm using this equation that I've developed every time, so I'm just going to rewrite it here. So the cost of renting a car and driving 1,200 miles. Now, okay, so I have C of m and I have m. You can really think of this is really just C. Think about this as C, okay? It's not necessarily C of m. C of m is just what it is in function notation. But if we want to really call this something, this is the cost, and here is the miles. So if we're substituting in this problem for the cost of renting a car and driving 1,200 miles, we want to find C of m, or in function notation, C of 1,200 miles, because I'm substituting for m, not only in parentheses here on the left-hand side, but more importantly, for m, the miles, because I'm given 1,200 miles on the right-hand side. Okay, once again, I'm just going to use a calculator to solve this. I'm literally plugging in 0.15 times 1,200, and what am I, plus 25, and I'm generating 205. Am I done? No, I'm not done. C of 1,200 equals 205 is not done. This is a model. I need to answer using units. $205. And you can go back and check to make sure your units make sense. It's asking what the cost of renting a car is. Makes sense that your answer should be a dollar value. Next one, same model. C of m is equal to 0.15 m plus 25. Okay, so 6350. Now I've substituted for m. I know that I need to basically substitute for the other one. That's another way you can look at it. I've substituted for m. The parts B and C, I'm going to ask you, give you C and ask you for m in one, and give you m and ask you for C in the other. Okay? So I've already given you m and asked for C. Now I'm substituting for C. So C of m is replaced entirely by 6350. 6350 is the cost. You can think about this as capital C, and then I'm solving algebraically for m. Okay, I'll walk you through this one. And that you're subtracting 25 from both sides. Subtract 25, subtract 25. I get 38.5 is equal to 0.15 m. And that m, once again, all I'm doing, in fact, let me not say this, because should be made clear. How do I solve for m? I'm dividing by the coefficient m on both sides. Divide by 0.15. Divide by 0.15. I'm literally just doing this 38.5 divided by 0.15 in my calculator. And I'm getting m is equal to 256.6 repeating in your calculator. So in your calculator, you might see on your screen something to this effect. 256.667. This 7 is just rounded. You should know that 0.667 is really just 0.666 repeating, as I put here. So if I were to write this in units, it's okay for me to say 256.6 repeating miles. 256 and 2/3 miles, you can even say 2. I'd accept either. So my final answer, 256.6 repeating miles. That's my final answer. Okay, next question. Lynn is tracking the progress of her plant growth using the following table. Okay, so I'm not going to go into independent and dependent, go into as much detail this time around. I'm just going to go and identify the independent and dependent, name them, and then give you the function. So, Does time depend on my plant height, or does my plant height depend on time? The plant is growing over time. It depends on how much time has passed. So therefore, the plant height is the dependent variable. I just noticed that Mr. Patterson always puts the dependent variable underneath the independent variable. Interesting. Interesting to note. Okay, so I'm going to say that H is the plant height. And I'm going to call T the time. Okay, therefore, my equation is now developed finding the slope and the initial value. So slope, easy enough. I'm just going to choose 2 points. I'm not going to write them in. I'm going to say 9 minus 7.5. That's this 9, this 7.5. I'm going to cross that out. That's 9, that's 7.5. Over, because I identified this as my y values, my dependent variable, so I know to put them in the numerator in the slope calculation. Over 2 minus 1 equals 7.5. So this is 1.5 over 1, or 1.5 or m. Okay, good. Yes. All right. Now let's solve for the initial value. This is increasing by 1. This is increasing by 1.5. So if I want to go back to 0, I need to decrease 7.5 by 1.5 to get 6. And I've developed the coordinate point 0.6, and I've identified my initial value as being 6. Therefore, my equation, h of t, is equal to the slope, which I identified as 1.5, times the independent variable, t, plus the initial value, 6. This is my equation, which I'm going to work with for B and C moving forward. B. I'll write this again. H of t is equal to 1.5t plus 6. What will the height of the plant be after 20 days? Okay, so am I given a value of the height, or am I given a time? Clearly time in days, 20. So, therefore, I'm substituting for h of 20 is equal to 1.5 times 20 plus 6. So once again, what I'm really doing is just identifying first in B, am I given a value of the height or the time? If it's time, I plug in for t. If it's height, I plug in for h of t. So what is, and that looks like 26. That should not look like that. My zeros tend to look like 6's, shame on me. Right, so what does this evaluate as? 1.5 times 20 plus 6 is 36. Am I done? No! 36 centimeters. Centimeters. Okay, so that's the answer for B. Next one. This was the mistake that I pointed out in class. So if you haven't done so already, please change this. It's not 37.5 inches. This should be 37.5 centimeters because my entire problem is in centimeters. Therefore, it makes sense that I should have centimeters. Yes. Okay. Now, I'm going to write my equation again. H of t is equal to 1.5t plus 6, because I'm working with the same thing again. I'm given 37.5. Now I'm given a value of the height, clearly. Although I can look up to B and say, okay, I'm already given a value of the time, so I know in this one I'm given the height, and I need to solve for the other one. Hint, 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 hint. Subtract 6 from both sides, subtract 6 from both sides, and I am getting 31.5 is equal to 1.5t. Divide both sides by 1.5, divide both sides by 1.5. My final answer is t is equal to 21. But wait, is it? No, 21 with a unit. Days. 21 days is my final answer. Okay, perfect. On to the easier questions, in my opinion. Number 3. Mr. Patterson had just joined an indoor soccer club, Ashley Soccer Dome. Incidentally, that's a real soccer dome. My very first soccer coach in elementary school for travel team. Love this man. Ashley Soccer Dome does exist in Montclair. He makes a gazillion dollars a year. Okay, at any rate, so Mr. Patterson just joined an indoor soccer club, Ashley Soccer Dome. The cost of membership is $80 to join, plus $20 per month. Write an equation, naming the variables using function notation that models this data. So, same exact process as before. We need to identify the independent and dependent variables. Okay. So, how do we do that? Let's see. One thing the independent and dependent variables definitively is not. It is not the initial value and the slope. Students were pointing this out left and right in class over the last week or so. No, no, no. We're variables. There are variations within the problem. It could take on this value or that value. If the membership cost could be $3,000, I could have stayed there 30 months. I could have stayed there 20 months. This could cost me $800. All these things are varied. What is set? The initial value of $80 and the slope of 20. Okay, so we'll come back to that. But my independent and dependent variable, because my total cost for membership, right, depends on how many months that I've joined, I'm going to identify C as being cost, okay, and T as the time in months. Okay. Now in this case, I don't need to solve. This is why this is easier. I don't have a table. I don't need to solve for the initial value. I don't need to solve for the slope. It's given. I'm going to underline them in blue. I crossed them out in red earlier. But this, $20 per month, how do I know it's the slope? Per, my rate buzzword, it's right there. It usually is. Over is another one. Every is another one. Words that surround, when you have a number that's surrounded by these buzzwords, you know that that's a rate. It makes sense, $20 per month. It's a rate, something changing with respect to something else. $80 to join, my initial value. So given that that's the case, I'm going to write my equation as C of T is equal to 20 times T. So, and this makes sense, plus 80. If you think about it, it doesn't make sense to have 20 plus 20 and 80 times T. Because I'm multiplying by T the number of months, $20 every month, and then adding the membership fee. So the right-hand side of these equations, like always stop and think. It really should make sense about what you're doing. Think carefully. It makes sense that I'm multiplying the independent variable by the slope. Or is that really an initial value? Is it one set cost? Or is it the cost that I'm paying per month? Okay, fair. So let's move on. This is the equation I'm using for B and C in this problem. Right, okay, same exact equation. C of T is equal to 20T plus 80, and I'm asked, how much money will I have to put in to playing indoor soccer this winter if I've been playing for 4 months so far? So what am I given? Time or cost? 4 months. Clearly time. So C of 4, and this is probably what confuses, I think, a lot of students. So let's stop here. It's true that I'm plugging in for T on the left-hand side, but that's just notationally what you write if you're plugging in for a value of the independent variable, time. So don't think of C of 4 as plugging in really here. It's just this is the way we notationally write the left-hand side. Where I'm really plugging in is this T up here, which I'll circle in red. This T. So that is 4, okay? I'm plugging in for 4 is T plus 80. So 20 times 4, 80, plus 80 is 160. Am I done? No, this is cost. Therefore, I am writing $160 for my answer. Next question. How many months have I had a membership at the club? If I've spent $180 there since I've joined. Once again, same exact equation. C of T is equal to 20T plus 80. I'm given $180. So what is that? Is that C? Is that T? 180, clearly. 180. I'm solving for T. So I'm solving, and think about it. If I'm solving for T, does that make sense? Are they asking me about a time? Yes, they're asking me how many months. How many months? Therefore, if I say T is equal to this or this amount of months, it makes sense. All these problems make sense. Okay, so this is 100 is equal to 20T, and divide both sides by 20, and we get t is equal to 5. I'm not going to shout about it this time, but we are not done. 5 months is the time. That is my answer for part C. Okay, perfect. Last question. Mr. Thompson is on a diet. He currently weighs 260 pounds. He loses 4 pounds per month. Write an equation, naming the variables and using function notation that models this data. So this is another one where we're given the initial value and the slope. We need to decide what are the variables. Hardest part of this, by far. Okay, so what's varying? Okay, he weighs a certain amount, he's losing amount per month. Okay, so potentially independent variable can always be time, especially if it is something happening over time. That's the way that you can sort of identify that. And it's easy to identify sort of the independent and dependent variable. Mr. Duncan was going over with this in a station via this phrase, the rate phrase. So pounds per month. This pounds, okay, and month are both units. They're units of measurement, right? So if you want to identify the variables, you can identify what are the variables that are represented by these units. Pounds, month. What are those? Pounds, weight, months, time. Okay, so let's write that in. I'm going to identify, because his weight depends on time, his weight depends on how many months go by. So if I'm capitalizing weight, that's my dependent variable. So W is weight and T is time in months. And we can say, just for clarity, this is pounds. No need to put the units, it's just to make it abundantly clear. Okay, because pounds per month is around 4, we know that that's the slope and 260 is the initial value. Now, this is a special case, and this is always something you should think about given the slope. If I'm losing 4 pounds a month, is this a negative or positive value of the slope? Losing 4 pounds a month. It makes sense that it's negative, right? So in this case, the slope is, I don't know why I wrote F, that doesn't make sense. W of t is equal to negative 4t plus 260. Okay, and it makes sense that it's negative because he's losing 4 pounds a month. This is the equation I'm working with. And your answers make sense. If you have an equation that's developed inappropriately and your answers for B and C don't make sense, then maybe you should go back to the equation. Okay. How many months will Mr. Thompson, after how many months will Mr. Thompson reach his goal weight of 220 pounds? So I'll rewrite once again my function. Now, 220 pounds, is that weight? Is it time? Clearly it's weight. We're substituting for the entire expression. This is 220, okay? We're substituting for that entire, not expression, that entire notation on the right-hand side that represents, that's in function notation. So this is going to be 220 is equal to negative 4t plus 260. Okay, now algebraically, this might not make so much sense. You might sort of catch yourself and say, wait a minute, this is wrong. If I subtract from 260 on both sides, I'm getting a negative number on the left-hand side. That's right. Think about this. This ends up being negative 40 is equal to negative 4t. If I divide both sides by negative 4, I divide by negative 4, what's happening here? I'm dividing by a negative divided by negative is a positive. Negative 40 divided by negative 4 is a positive 10. So it makes sense that my time ends up being a positive value, 10. Once again, not 10, 10 months. Okay, last part. How much does Mr. Thompson weigh after 5 months? Clearly, I'm using the same equation that I developed, negative 4t plus 260. 5 months is a given time, so this is W of 5 is equal to negative 4 times 5 plus 260. Evaluating this whole right-hand side, negative 4 times 5 plus 260 is 240. Am I done? Once again, no! 240 pounds. And that's 240. And the curse of my zeros looking like sixes here. 240, 240. Okay, all right. Hope you enjoyed this video. Hope it clarified this for you. Please post any questions you have in the comments thread in Edmodo. Ask me any other questions you have via Edmodo. I'm happy to post other videos between tonight and tomorrow to help you do well in this test. That's my only goal. Okay. Bye-bye.